All right, as I was saying, welcome back for lab number 2. We're going to try to get it all going here. And today, as you can kind of see on the whiteboard, we're going to have a little review of what we talked about last week. You know, after kind of watching the last playback, you know, it kind of dawned on me that, you know, there's a couple things I just need to say and make sure you guys get, because look, all kidding aside, this can be a really, really confusing topic. And I mean, you can get lost in it so quick, it's not even funny. So we'll review a few things here today. And before we get into the manual delay compensation thing, I also discovered a couple of things on S6L that I'm going to share with you that I didn't know were in play in regards to some delay compensation that has obviously been that has taken place under the hood that I didn't know about, which is really cool, actually. It's going to work out to your advantage for sure. Also, last week, my friend Paul Dalen was asking about, you know, what comb filtering would sound like on a vocal or a guitar, etc. So I've got that kind of set up where I can demonstrate that a little bit. So hopefully we'll get through this fairly quick here and do that. And I'm going to start. Well, let's just start with some Q&A a little bit. I won't go too long here because we're going to run out of time today, I'm sure. But anybody got any questions that you want to talk about from last week? You need me to clarify something, go over something before we get started here? Now, you were all talkative a few minutes ago. Now, nothing. Okay, well then.
I got one. I got one for you. Would you ever consider putting like a pink noise source on your snare drum and looking at all your microphones on your drums for the manual, for the, you know, the physical difference in the microphones? Or
not only would I, Sully, but I have on a regular basis, and that is going to be one of the labs. I knew that was your answer. That's why I asked. Thanks for being my setup, man. Yeah, absolutely. You know, just kind of doing microphone alignment, things like that. Yeah, I have a snare drum that has a powered speaker and an interface built into it. So we will do that in one of the labs coming up for sure. I was thinking about that last week, that would be a pretty cool one to show. I think I can do it here with an overhead camera to kind of show what's going on.
Down and dirty would be a Bluetooth speaker sitting on the snare if you didn't have a actual snare.
Well, yeah, and actually I'm going to show you a little additional thing there, which is how to get your overheads aligned properly left to right on a snare drum to put that snare image right dead center, and also make it be able to collapse a pair of overheads down with absolutely zero penalty and comb filtering on it. So it's pretty cool. I've been doing it for quite a while now, so I'll show how to do that. Use Smaart how to do that. Okay, so no other questions before I carry on there? Christopher
Robert,
Dean?
Yes, this is not S6L specific or even venue specific, correct?
A couple of things I will show you today are S6L specific. All of the stuff we talked about last week outside of venues delay compensation applies everywhere, right? I mean, the concept definitely applies everywhere. It's just how you go about managing it on your given console, right? Follow me there?
Yes, thank you.
Yeah. All right, so let's review a little bit here. I think I got my Smaart going here. Let's just make sure. Yeah, okay. All right, so let's start with the discovery, what I discovered last week. And I thought I saw this happen last week when I was doing this. And I decided to come back and just kind of check on it. Now, if let's go to my share screen here. You guys, yeah, you all see my venue software, all this other stuff, right? Smaart, blah, blah, blah.
Yes, we do.
Okay, great. Yeah, if somebody can just be a little bit of a confidence monitor for me here, it'd be great.
We see the luffs.
Yeah. All right, so one of the things I discovered this week, and I don't know when this happened on S6L, because I don't believe it was like this when we first released it, but maybe in some of the underlying work that they've done over time on it, I think they might have just dealt with this. So here is some pink noise coming to you right through the left-right bus, right? And now I'm going to assign that to a subgroup that is also assigned to the left-right bus. Let me just do this one. There's no processing on this group. It's just assigned to the subgroup. So you remember we created that dual path there, right? Where an input is assigned to the left, right. An input is also assigned to a group to the left, right. All right, so check this out. So I'm going to turn on the group now, and you'll see the magnitude trace elevate, which means we're getting gain there, and the phase trace does not shift. So that alignment is already being taken care of somewhere, right? The phase trace doesn't lie here.
You're saying that's happening without, right, you have everything off right now, mix and inserts and everything's off.
If you look at delay compensation, it's off right now. Right? So fascinating. It kind of threw me for a curve. I mean, I literally looked at it about 10 times thinking, is that right? Is that actually right? So obviously the guys have done something underneath. And I'm going to bet they dealt with it when they started putting the delay compensation into the matrices. You know, they probably just went ahead and handled it. Now, obviously, if we have a group that's got processing on it that we're adding with it, then we got all kinds of problems, right? Then we have to use the delay compensation there. So, you know, if we did this, then that should tidy it right up, right? How's the noise level to you guys? Is that too loud, too soft?
It's good.
Okay. All right, so does that make sense to everybody there? I mean, like I said, that's just something I just discovered. So the beauty of what comes with that is that if we were doing a parallel compression with a source and a group, you know, that double path, right? Then we could do that parallel compression without plugins, right? And no delay compensation. This is really this is going to be a really important one for monitor guys because they won't have to have delay compensation on to be able to do this.
Great.
So hang on one second.
It's only beneficial though with like the onboard dynamics or that kind of thing.
That's correct. Yeah, and that's exactly what I was going to show here. So here. So this is that output, right? So if I put the compressor in and the EQ in there, notice no change in phase trace. We haven't elevated, you know, lifted time there. We've just put processing in place. So now you have equalization and compression as a parallel source on that group. Let me do this too. There. All right, so this is the noise source. This is the group. This is the left-right bus, right? And as you can see there, as I turn down that group, magnitude trace goes down, magnitude trace goes up, no change in phase. I've got inboard, I'm going to start calling it inboard dynamics and EQ on that group. All right. You can start to see me put the filter in there, whatever. Pretty cool, right? Good little discovery, that's for sure. The other one that I started thinking about after our session was over is what if you assigned that noise to an aux and assigned that aux to the left-right bus, right? Same thing, right? So this is aux master now, aux master. This is noise going to that aux. That aux is assigned to the left-right bus. So this is a parallel path now too. Anybody scratching their head on that one?
I am.
Yeah, it's nice though, right?
Yeah.
I mean, gosh, if you had to walk up to a console and work fast and still wanted to do parallel work, you know, you wouldn't have to worry about the whole latency thing. You know, just do it. Go, use the inboard and get on with it. Like I said, the phase trace doesn't lie here, you know. I encourage you to experiment with it.
A great discovery.
Make a liar out of me. I encourage you to. You know, that's what this is all about, really.
Now we just need the onboard compressors to have multiple different character modes.
Well, now you're going to go muck it all up, you know.
You knew it was coming.
Well, you know, we can do that, obviously. I mean, obviously, you know, just use the delay compensation principles we talked about and insert them on the group or the aux and go to work. All right. So that's pretty cool. That was a nice little discovery. All right. So let's start talking just a little bit about latency. I want to make sure I clear the air here just a little bit and make sure what I'm saying is what you're hearing, and it's what I mean. Mute your mics, please. Mute your mics. Everybody, mute your mics. Okay, you're gonna make me do it. Okay. And here come another group of people. All right, so latency. Okay, so in the discussion last week, after I kind of watched the replay, I started thinking, okay, I need to make sure that everybody understands this. If an input has latency on it as a result of a plugin, right, that is not in and of itself going to make it comb filter. It needs a like source to be added with it to start to experience that frequency rub or that impulse offset, right? Just the fact that it's latent doesn't really mean anything until you start adding other things with it in context, right? Does everybody kind of get that idea? Because I got the feeling that Paul was kind of asking that last week, like, well, okay, if I put these on there and it's creating that kind of intermix, rub in impulse and frequency response, what is that going to sound like, right? How do I hear that? So I decided to take, just get some tracks up and load a vocal in here and create a parallel path for it, just so you can kind of hear it to begin with. So I've got a vocal here. Let me do this. And let me see if I can do this. There we go. So tell me if you hear this.
Walked over centuries.
Yeah. Everybody hear a little bit of that?
I hear that, yes.
Okay.
Yes,
hang in there with me. So, so we got guitar there. Stand by for me.
Haunting my sickness. I walked over.
Okay, so this is creating a parallel path for that vocal.
No man could give to me. Haunting my sickness. I walked over centuries.
Now I'm just going to mute the parallel path and listen to what happens to the frequency response, right?
Give to me, haunting my sickness. I walked over
All the hollowness goes away and all the weird shifty stuff in the middle.
Yeah, all the buzzy top end kind of goes away too, right?
Haunting my sickness.
I mean, let's face it, guys. I mean, we got at least a millisecond worth of offset here between the source and that second path that is coming up there, right? And so, it's if we were gonna create a flanger for that vocal, what time would we use on our device? Probably about a millisecond or two, right? To create the flange. I mean, that's what you're hearing there. So the question becomes, and this points to a bigger discussion that we'll have at some point. How do I go about creating parallel paths for somebody or something at the input and keep it in phase, right? Because obviously, if I go to this input and I start, turning up delay on it, it's going to delay the downstream path of it as well, right? Remember, this is going direct out of this channel and returning to this channel. I want my parallel path to be post fader, right? If I turn down one, it turns down both. Everybody with me there?
Yeah.
So the question is, how do I get this all in phase, right? And the only way I've come up with how to do it, and I'm open to suggestions for people. The only way I've come up with to do it is to create what I call a bridge channel, right? It's a way, and remember the confines of this discussion are I want everything downstream of this main vocal to be post fader. If I mute it, I want it to mute the other stuff. If I turn it down, if I drive it harder, I want it to follow the fader, right? So maybe this is distortion or something else we're putting down, or maybe extreme compression. So I want it to follow this. Well, the way to do it is to create a bridge channel, right? And the way we do that, or the way I do that, I should say, is I take an auxiliary out. In this case, I took the direct out. We're just going to use the direct out. And take it out and return it to two places, right? So right now we're going direct out of the channel, into two plugins. I'll try to annotate it here where you can see it.
Could give to me, haunting my sickness.
Hey, Rob, can you dip the artist a little bit?
Yeah. Thank you. Don't be afraid to tell me that too, guys. Like I said, I'm flying a little bit blind here. So.
Could give to me, haunting my sickness.
Come on, annotate. There we go.
I walked over centuries.
So right here, if you notice,
No man could
I've got two plugins there that are both being driven by the same direct output, right? So direct output to two plugins, but they're returning to two different locations. And that, if you look at the camera again, that's here and here, right? These are the two returns of that plugin. So the way we're going to do this is we're going to take this primary vocal and we're not going to assign it anywhere, right? We're going to take it out of left-right drive so you don't hear it now. But now you can hear the bridge channel and the return channel, right? Everybody with me? Now, obviously, one has got processing on it and one doesn't, right? So I've got to delay one of these channels to get it in time with the process channel, and it needs to be the bridge that you delay. Okay? So, you know, you would...
The dry one, basically.
The dry one, yeah, this guy. Because here's what's... Actually, I'll just do it here. I'm just going to fudge it. So I'm going to put in some delay here. We're in sample resolution. And a matter of fact, I'm going to do this. Make sure the processing is...
Haunting my sickness. I walked over centuries worth of land no man could give to me. Haunting my sickness. I walked over centuries worth of land no man could give to me.
All right, so what you're going to watch here is this. And this is a hack, by the way, too, of how to do this without an FFT. So where I want you to watch is here. We are in sample resolution on this input. This is the bridge channel. That's this guy right here that we're adjusting. Okay? Now what I've done is reverse the polarity on the slam channel, right? All processing is bypassed. There's no equalization, no high pass filters anywhere. The processing is instantiated but bypassed. Okay. If you look up here, let's see. On the right side here, you'll see two areas here. So the right-hand side is the process channel. The left-hand one is the bridge. So you can see there's processing and instantiated on that return channel, but it is bypassed, right? Not uninstantiated, just bypassed, right? And once you do that, where you can make where these two signals are identical, reverse polarity on this one, right? So that guy is reverse polarity, and then I'm going to start manipulating time here until that signal goes 100% away. Oops, I gotta go back over here, sorry. Oops, no man could give to me, haunting my sickness. I walked over. Whoops. All right, so there it is. 171 samples. Right? Everybody follow that process there? So now if I reverse polarity again, or put it back to normal polarity on this process channel, it should come back in full glory here. Haunting my sickness. Right. So here's our compressed return. I'll go ahead and put some processing back in on that now just so you can hear the difference. No man could give to me. I think I probably got something pretty extreme here. My sickness. I walked over centuries worth of land no man could give to me. Haunting my sickness. Okay, so everybody kind of get the idea there? So you're going to create a bridge channel for that parallel path, right? So that you can get them in time. And here's going to be the beautiful part of this. Once we get this aligned, where I can have this parallel path happening and have it in phase, we're going to lose sight of this. We don't ever need to even see this again. I'm going to put it right at unity, and then we can just get it out of there. Layout sign and take it out. Right. Then, you know, on your layer or wherever you want to work, you can have your vocal and your parallel path of vocal here.
I walked over centuries worth of land.
Everybody follow that?
Could give
me some thumbs up, Sean. I'll get to your question here in 1 second.
My sickness.
People in,
yeah, it's really awesome, man.
Centuries worth of land.
So I usually just take this channel, this bridge, once it's done, and just move it down to the bottom layer, as far away as I can get it. I don't need to mess with it. All right, let me take a couple questions here. I'll stop our little friend singing here.
Sorry, is the vocal bridges still going to the left and right?
Vocal bridge is going to the left, right, or whatever bus you want it to go to. The primary, the mic input, is not going anywhere.
Oh.
This is not assigned anywhere. It can't be assigned anywhere because it's always going to be out of time of these. You follow me there?
Gotcha.
So primary microphone is not assigned to any output bus. Direct out or aux out, however you want to do it, and then return to two places. This is the dry vocal. This is the processed vocal. And you need to align those two channels. Sean, go ahead. Sorry, I didn't mean to step on you there.
So how close is your phased delay time, which you said was 171 samples?
Yeah.
How close is that to what's reported in the plugin window for the process channel?
Let's have a look, shall we? All right, so let me clear my annotation here for a second.
Just had the same question. Thank you, Sam.
All right, so I'm sorry, I'm gonna have to go over here for a sec. All right, so there is our process channel. Somebody might have to do the math for me here. So here we have 171 samples. 171 samples. That sounds familiar, does it not?
Yes.
That's what you delayed the unprocessed channel to.
That's correct. And you know what that also tells me then is that the samples of going to the direct out to the return, well, let's see it. Let's think about that now for a minute. Because it's coming through plugins on the return here. Right, so there should be additional latency there.
Well, there's 7 in the trim plugin, 7 samples there.
Right, right. But it sure, I mean, the math sure worked out right there, right? But again, and I'm just going to keep saying this until everybody is so sick of me or they believe me. Either use an FFT or use pink noise out of polarity to verify your path.
I'm really more concerned with, like, you know, say you're a church mixer and you get somebody different every time, and it's, you know, who knows who it is, and you have no time because they don't care about sound checks and this and that. Is it feasible to just look at what's reported and delay? You know what I mean? Like here, that's exactly what happened. What was reported and what it took worked out. Yeah. So is that scenario feasible option for someone who just has no time to mess with things? All they can do is see what's reported and go do it. It's
better than not addressing it, for sure, without question. And I'll say this, you know, I actually meant to kind of lead with this and I didn't do it, but I want to do this. You know, we're talking about this time alignment procedure today, and we're going to go deep in it today. We're going to go deep into manual delay compensation today. I want to contextualize this a little bit by saying, look, this is not a showstopper, right? The show is going to go on whether you delay compensate or not, but it's going to have a dramatic impact on how you do the gig, how it actually sounds, how you respond to inputs when you try to mix them together.
Yeah, yes. I've got a question for you.
Yes, go. Barney, is that you speaking?
It looked like he muted his mic.
I haven't. Well, I'll try.
Maybe he was talking to somebody else off screen.
Take the mute all off here for a second. Might be me. Okay. Try it again if you were asking the question. See if you got it now. Oops. Unmute all. Let's try that. There we go. Please try to be conscious about muting your mic now because we got a lot of people in the room. So whoever was speaking earlier, try it again, please. One more time. Everybody, please mute. If you're not going to speak, please mute. All right, I'll come back to you if you have the question. Ricky, have you got a question there? Sully, if your question is done, please pull your hand down.
Sorry, I forgot to lower my hand.
That's all right.
I notice on the main input channel that there was a delay of 20 milliseconds?
On the main input channel on this guy? Yeah, that was probably a leftover from me messing with it a little bit, doing some other stuff. But you could do that. I wouldn't necessarily encourage you not to do that. And I'll explain why when we get into full manual compensation, because
there's a reason for this.
There could be. Yeah.
You're going to have to mute everybody, Robert. I don't think people are paying attention or listening or something because a lot of background noise.
All right, stand by. Oh, boy. All right, Sully, are you able to unmute right now?
I am unmuted right now. I just did that myself.
Okay, good. Then I'm just going to leave it like that. So they'll have to unmute if they want to come in. So, sorry, who had their hand up there and wanted to ask a question again there? I saw it. I'm sorry, I spaced the name. Did we get them all? Anybody else with a hand up question?
You answered my question about the input delay of 20 milliseconds.
Great, okay.
I don't currently see any hands.
Okay, me neither, yep. All right, so everybody kind of get that, right? Paul, did that answer your question in terms of being able to hear just comb filtering on the vocal?
It was super helpful, and everything you went in after it was great. I realized the real root of my question was not so much what would it sound like, but would you be able to identify it on the fly? Like if you walked into a show,
yeah,
or if you were at the console, or would you just say, something's effed up, I don't know what it is, and now I need to dig in and figure out what it is?
Yeah, that's exactly right. And we'll discuss that. I'll try to give you a real example of that when we start. Actually, I'll do it here with the guitar. Let's do the guitar for a second. Maybe that will show it as well. Let's see here. Stand by for me. Let me just make sure my assignment's right here. Right. Okay, so let's say you just walked up and the guitar sounded like this. And especially in the context of a mix, right? Let me make sure. I mean, would you pick up on it and say, wow, that's comb filtered? There's duplicate sources adding together there. Well, until you took away one.
I think because guitar players are so 100 pedals that add similar stuff to this, it might be hard to tell on a guitar rig, if you're just a punter.
That's exactly my point, bringing it up. Well, not even a punter. I mean, one of us walking up and hearing it would be like, well, has he got some sort of out-of-phase pickup thing going on there? What's going on? Would you pick up on it and go, oh, wow, no, that's a pair of sources that are flanging there, that are comb filtering there. It's tough to pick it up,
And I don't know if you agree, Robert, but I think it's important to point out that the time differences due to inserts really only matter on stuff that is extremely heavy amounts of bleed in something. Like, so if your floor tom has got this plug-in and and is not exactly in time with your kick drum as far as, samples are concerned, if there's no bleed in either one of those mics from the floor into it, you're not going to necessarily ever notice that problem being 10, 20, 100 samples out.
Yeah, you might not for sure. But, the thing as we start to go into the presentation here, the thing you need to understand, though, is as we start to shift and disconnect inputs from the output, meaning everybody's arriving at a different time. Yeah, we've changed the phase and the impulse relationship between those inputs, right? But also all of the background noise, right? I mean, there's offset there anyway because of propagation, but now
right, cumulatively it becomes a problem.
Yeah.
As far as one or two things being different, you might not even know.
Yeah. And, you definitely get to a tipping point with it, right? I mean, you might be able to get away with, few inserts here and there, blah, blah, blah. You're kind of working thinking, okay, everything's all right. But I'll speak from personal experience here. At some point, kind of building show file and moving and adding and blah, blah, blah. At some point, there was a tipping point where I just kind of went, okay, hang on a second here. Something is not right, And once I went to delay compensated console, I never ran into that problem again, once you commit to it. So, Paul, did that help your idea there of being able to kind of pick it out? Because I mean, it's hard.
Oh, well,
to pick
perfectly, just only in regards to, yes, I agree. I would just say that's an odd choice of a guitar sound.
Yeah. Unfortunately, you're the one making it, Right. Okay. Well, let's, I think we probably got through enough of that there. Let's move on to our actual topic today, since we spent, half hour reviewing here. Let's go, leave that off for a second. Let's go to this. I'm going to give you guys a little edited version of a presentation that I put together and I've delivered a few times. This is like I said, a kind of a Reader's Digest version of it. I'm just going to give you pieces of it, but I think it'll help get the point across of what we want to accomplish here. So I'm going to do this for now. Just pull this up. You guys can all see that nice and big. Yes.
Yeah.
Okay. So, we kind of talked about at the last presentation, that in live sound now, we're right about at the point of history where recording engineers who were trying to mix in the box were about 10 years ago, maybe even a little bit farther back. And the question is anybody noticing that this is happening in their show files and in the consoles, right? So the idea is this, I thought, well, really ultimately what we want to have happen, whether we even actually realize it or not, is we want our digital console to have the same impulse capability as an analog console when we add things together, right? We don't want it to sound different because of this, this offset latency issue. So you have to take a couple of things as constants here. Please don't drag me down into the speed of light argument, et cetera here, okay? So if we have any number of inputs coming into an analog console, right? All of those inputs are going to exit the console at exactly the same time. Create a fully additive impulse. And remember now, when we're talking about music, right, we're talking about two things that need to add together. The frequency response, they need to be complementary across all inputs, and the impulse, right? It's the two things, right? Even if we shift time enough to get all frequency together, if impulse is not together, it's not going to sound musical. The band's not going to sound tight. Your mix is not going to sound tight, right? So there's two things in play here for music. Now in analog, if we start to do inserts on these channels, and I'm talking analog inserts here, no digital inserts allowed here, the same thing applies, right? I still get all of the inputs exiting the console at exactly the same time, right? Yeah, I've got to let less banks in here. Les, you're late. Bring a note from your mother. All right, so that's ultimately what we want to have happen in digital, but obviously in digital, it's a little more complicated than that, right? So if we move over to digital, the important thing to understand is if I have inputs coming into a digital console and I'm only using the inboard processing, right? The inboard, gates, compressors, etc., then all of those inputs will leave the console at the same time, right? And believe me, you got to dig so deep down into the weeds to really understand this console to console to console. I mean, this is why I'll use Allen and Heath as an example because they do a great job with this actually, where they kind of label their things as plugins, right, in their console. But it's all internal, right? It's all Allen and Heath processing. It's all accounted for in the throughput buffer. So when you put on their plugins, it's not actually adding time to the channel. Same thing applies in Yamaha, really. It's a very controlled environment there. It's not going out of the console to come back in with processing, anything like that. In those environments, the console throughput stays stable, right, regardless of how much processing you put on, okay? So that's true of certainly of S6L and most digital consoles. If you're using the inboard processing, all of the inputs will exit the console at the same time, albeit maybe 2 milliseconds later, right? But at least they're all leaving at the same time, which is our ultimate goal here, okay?
Robert,
Yeah.
Yamaha does have latency in them. It's like 0.3 milliseconds. I actually was curious about it and I timed it myself.
So they're
it's like point.
Yeah.
Yeah.
So their plug-in processing has that?
Yeah, their internal plugins do have latency involved in them.
Wow, I didn't know that. Well, it's good info, good intel there for sure. I think certainly after you see this.
Their premium and rack ones definitely have up to about a half millisecond delay, depending on the console too. That depends on the DSP usage.
Right. Yeah, good intel there. Okay, so in digital now, if we start to put plugins on channels, right, external plugins, we're going out to DSP and back. Then now we've got time offset between channels, right? Now we're going to have a staggered output. We're going to have inputs that are going to leave the output of the console at different times, right? So how do we account for that? How do we do that? Because there is no input delay compensation, right? Nothing will automatically calculate this for us. Well, we can start putting delay on the non-plug-in inputs, time back to the longest source, right? We can use it as a reference and off we go. Now all the inputs, even with all their processing, are going to leave the console at the same time, but at a much later time now, a much later overall time. Your console buffer is bigger now, right? Everybody follow that? This is what's happening. I guarantee you this is what's happening out in the world. And I really don't believe enough people are paying attention to this. All right, so what happens maybe if we use a wave server, right? Well, wave server has the same issue now. Remember, we're combining wave server with our console here. So obviously within that unit, there are going to be different throughputs unless we turn on their delay compensation. And if we do that, it will compensate the server, but not all the surrounding inputs that do not have waves inputs on them or waves processing on them, right? We would still need to delay non-processed, non-waves processed channels back to the server. Okay? Anybody want to raise a hand, ask a question there? Now's a good time to do it. So that's it.
Hey, Robert?
Yeah.
So is this pretty much like the same principle as back in the day with, say, Pro Tools? 8 is where you're doing the manual delay compensation because of the plugins that you're adding.
This is exactly the same challenge that Pro Tools had before HD and that when they built the delay compensation engine into Pro Tools. Exactly the same process.
So we're just doing the same thing. I'm sorry, go ahead.
Yeah, we're essentially doing Pro Tools 8 here. That's right.
Okay, thanks, buddy.
Yeah, no problem. Hey, mute your mics, please, if you haven't. James, you got a question there? You got your hands up? Or hand up, I should say. James Clark?
Yeah, hey, I was asking in the chat, but I'm just curious, do you change live? And if so, do they change your...
You kind of cut out there, but I think you said, do I change plugins live?
Yeah, do you change... So if you go from drum parallel processing to some other effect or processing, I assume that because it's a different plugin, that's going to change your delay time? Like, what do you do to... Do you do that? And if you do, how do you account for that?
Yeah, I would never instantiate a plugin during a show. All right, so, but I may have, I do this on my parallel path. I have 3 or 4 different processors in that and just choose which one I want to use song to song, but they're already instantiated, right? The time is already accounted for, right? Does that answer your question there?
Yes, it totally does. Thank you.
Awesome.
So you're saying if they're bypassed or on, it's the exact same time.
That's correct. And that's key to understanding what we're going to do coming up here in terms of manually doing this, right? So yes, if the process is in bypass, it does not manipulate the time. If the plugin is uninstantiated, now you've taken it out of the circuit, right? Follow me there?
That is an Avid specific thing. Like I know that several consoles don't do it that same way where you can enable or disable them. But in an Avid console, it's like Pro Tools where you can mute and unmute a plugin, but it's still in the chain, or you can bypass it, and then that changes the delay.
Well, you're using the word mute there, and I'm going to assume you're assimilating that to instantiation, right? I know I went round and round with a couple of guys I was trying to help do this. We were using UAD stuff, and they kept taking it out of the DSP. You know, I think I can't remember the actual term that was used there. Maybe it was mute. But it would take the processor out of the circuit as opposed to bypassing the process on it, right? So the key to this is you want to have your time accounting in play all the time. You don't want to start shifting the inserts in terms of their time, right? Does that answer your question there? Or I see you look like you're deep in thought there. Like that might not be the case on some other consoles, right?
No, that's what I meant. I shift back and forth between a Venue and Pro Tools and a D-Live. So sometimes verbiage kind of gets a little bit fluid.
Without a doubt.
That was when I switched to a Venue. That was the biggest thing, was the button that turns the instantiation on and off versus enabling it in the chain are two separate places. And those two separate steps are not always present in all consoles. Sometimes in a console, when you turn the plugin off, like you turn the plugin off.
Yeah. As in uninstantiated.
Yes, that's correct.
Yeah. So the point is, you got to be careful here. You got to know that when you're doing this, right? Brian, you have a question there? A comment? Brian Norwood?
Yes. I just wanted to ask, hopefully this sounds all right because I'm using cheap headphones, but
you're good.
So if you had a multifaceted program where you had someone that was speaking and they were also on iMag, would you just basically leave that alone? Or how much time are we talking about? Is that going to throw off the frame rate of the video?
Yeah,
so
now you're
speaking after.
Now you're throwing a whole nother ball of wax into play here. Yeah, now keep in mind, I'm not talking about syncing to video here at all. And it would definitely mess with that. You would definitely want to account for this, especially if you're going to build a console buffer that's been time aligned. You are going to have to account for that and leave it alone so that video can sync to it, right? You may even delay past the video, so especially if you're doing stuff to video here, that's a whole nother ball of wax here. It's a whole nother ball of time alignment that you need to do, getting synced back with this kind of processing in play. It's tough.
And if I could follow up with one more thing, what would you do in terms of, like, if you're in a room situation where you can hear the band off the stage clearly, would you then take your output delay and match it to that at some point, or would you just let that happen?
No, those are two different processes there, right? In the first, we're trying to get our console to allow the inputs to all exit at the same time. And then what you're talking about is trying to account for a propagation alignment, right? Where I'm trying to get a PA aligned with an acoustic source in the building, right? Did I understand you right there?
Yes, that would be a better way of saying it.
Two separate processes there. The first one that has to take place first is getting your console in alignment. After that, then you can start dealing with, propagation delay and get your PA aligned to your sources. And I'll give you the bloody story. I actually went through this when I first started doing this. I was doing some pretty extreme alignment stuff, and I was using a pretty extreme subharmonic processor that was really latent. I mean, it had a lot of latency in it. So it was going to be the longest path that I was going to delay to. And by the time it was all said and done, not to dig in too deep here, but my entire throughput buffer was about 18 milliseconds on the console. And it sounded fantastic. I remember being so excited, listening on control room monitors, just thinking, oh man, this is going to rock. Got into the big room, band is set up, PA is set up, pushed up the master fader, I can hear the back line before I can hear the PA, right? So all of that work kind of got trashed. I had to go back and find a boundary where I was like, okay, I can't have any more than about 11 milliseconds of buffer on the console. Otherwise, the band is out in front of the PA. You follow me there? So those are two different things. And it kind of like what me and Sully were talking about last week, there's two processes here. And it's better if you use the right language with it. We're dealing with latency, inter-console latency here that we're trying to solve and get aligned. And then outside of that world, it switches to propagation, right? How long did the snare drum take to get to that microphone versus that microphone, et cetera? If I want to do additional alignment, then I have to do that after that initial console alignment is done. If you don't, you're just going to chase your tail. You're going to go round and round and round. Because one's going to affect the other. You need to create this as a constant on your console. Okie dokie? Everybody with me so far? Anybody's head explode yet?
Yeah, not yet.
Good. Okay,
lots
so
of pre-production, lots of pre-production.
Well, you think so, but I mean, and again, we'll probably do one lab, or I'll do something specifically on this concept. I have template show file that I walk into every show that I do with, right? That's already pre-aligned, it's already pre-processed, et cetera, but all the processing is in bypass, right? So not to go down that, but there are ways to make it where you can work really, really fast once you get the initial work done, show over show over show, okay? All right, let's carry on with the little prezo here. So we've time aligned to our wave server now, and again, we've got all inputs exiting the console at the same time, so we're winning right there, okay? So here's kind of what is happening, right? Just another little visual example of what's trying to happen here. So if we have plugins kind of scattered all throughout our console, as you can see here, I've just done it on some basic things here just to kind of illustrate the point. You can see that what is happening is we're messing with the impulse of our console, right? Of our mix. It's actually our mix impulse that we're messing with here. And we have enough of this going on in the world of live sound to begin with. We don't need to be adding to it here, right? So the way we want to get around this is to do this alignment, whether it's, I won't say whether it's automatic because nobody does it automatic yet, but here's what we want to achieve, right? We want to achieve, oh, I missed one of the automations, I'm sorry. At any rate, we want to be able to do enough delay compensation. Oh no, actually this is right, I'm sorry, I got ahead of myself here. So if we look at this, after last week, it kind of prompted me to go do some digging. And I went back and looked through some of the documents I had for some of the original, the complete front of house engineer seminars that I did in the late 90s and early 2000s. And I remember this doc was in there. And I thought this would be a really good way to kind of show the effects of this when it's not dealt with, right? So this is from John and Helen's book. I think I got this during sim class, probably in the early 90s at some point. But what you're seeing here is two sources, right, that are offset by a millisecond, right? And remember, out and back on our PCIe bus right now is almost a millisecond, right? So before you even got processing it. So if we were to say, okay, well, this is the base DI, right? It's happening at this time. And here's our base mic, and it's happening at this time. Well, look at the degrees of offset per frequency there, right? It's not something that's going to be solved with a polarity button, right? You might be able to pick a choice of which one you like better, but these are not in alignment, right? You see our comb filtering formula in play there. Let me see if I can get to it here.
Even an all-pass filter is going to only let you pick where you want it to be in phase.
Right, right. So if you notice here, right, in our 500 hertz, right, this is a 1 millisecond offset, and you can see that that's complete cancellation at 500 hertz there between base DI and base mic, right? So, if I start putting a lot of processing on the base DI and just leave the base mic in the dust, they're never going to add together properly, right? They're never going to add together properly. You've got to get them in alignment to begin with, right? Here's another example of it, right? Maybe it's the bass drum, right? Maybe we're going to put a lot of processing on our bass drum, but not on our base DI, or there is some sort of offset between those two things. Well, of course, they reside in similar areas in terms of frequency, and they certainly need to be together in terms of their impulse, right? If these two things start shifting out of time, right? They start shifting out of time. In this case, the bass drum is leading the bass guitar in impulse, and also you have a lot of cancellation that is going to go on. It's going to make it tough to add those together. Your chances of getting good tight bottom end with this decrease with every plugin you add, right? Because remember, the lack of low end, or the reason the low end doesn't sound right here all of a sudden, is a function of cancellation. So if you turn them both up and you think, wow, okay, man, I need some more bottom on my bass guitar there, you can turn it up all you want. You're just going to make the cancellation deeper because it's a function of offset. It's a function of time, not level, right? Okay, so that's kind of what we're trying to solve here. We want all of these signals to have the same starting point, at least, right? Keep propagation out of it. We're not going to deal with that yet. We're trying to not, corrupt this whole mix impulse with things that we were doing on the input side. You with me?
Copy.
Yeah.
Yeah, it's super important. And in live sound now, we're just glossing over it so badly right now. So badly. Alice, yeah, have I got your name right there? Stefanachik? You have your hand up? Go ahead. All right, I'll assume he is not going to ask a question. All right, so once we do that compensation, as you can see here, now all of our inputs are going to leave the console at the same time, albeit just a little bit later, right? So that's what we want. We want to get that impulse back together, and that's going to ensure that they have the best chance to add together in terms of frequency response, et cetera. Because even if you took the approach of, I've kind of had, I don't want to call them arguments, but discussions with guys that say this. It's like, well, if I have one signal and another signal, and they're two very different frequency responses, like this guy has no bottom end in it, this guy has all bottom end and no top end, then it really shouldn't matter, right? They should add together. I mean, it won't matter because there's no overlapping frequency response. Okay, I'll grant you that. But this is music. The impulse still needs to be together, right? We still want the impulse together. I mean, if that was true, then I could delay this one way out. And that argument doesn't hold true, right? Because now their frequency response addition is not mattering because they're in two different frequency ranges, but the impulse is completely wrong now, right? You follow me there? I know this is a tricky subject, man. Tricky subject.
Hey, Robert.
Yeah.
Hey, I was just going to say that it really makes a lot of sense because this would just totally set everything up, to be able to really tune the PA properly, I would think at this time too.
Oh man, if you're tuning PA with tracks as opposed to using CD or anything, and you don't have this sorted out, man, you're in a world of hurt.
Yeah, it just seems like it puts everything right in order right out of the gate,
Yeah, because you're going to blame things on the PA that are actually happening at the input stage.
Right, you're going to hate 250, and it's not the problem of the PA. It's a couple sources making it weird.
Guilty as charged. I've done it. I have absolutely made that mistake. Absolutely
Awesome.
done it.
Yeah, makes sense, man.
Troy, you have a question there. Troy Narworld. Sorry, I'm terrible with these names.
Is there a good way to measure this on a basic board like an X32? Measure the delay coming in from the effects or anything like that?
Yeah, I'm going to give you a hack to do it. I kind of showed it earlier. I don't know if you were here. You can use pink noise to do these kind of alignments and actually do it really effectively. More so, you can do it more effectively in digital than you can do it in analog for sure, because in digital, you should be able to get down to the sample and create absolute 100% cancellation between two sources. And once you've done that, then you can say they're in time with each other. Now just reverse polarity and off we go. It's not 100% accurate because you could just rotate it enough to get more cancellation, but it's a really good hack. I mean, I used that in analog for years doing this kind of stuff in propagation.
Yeah, because the X32 will only do milliseconds. It won't do samples.
Oh, that's a bummer. That's a bummer. You'll have a tough time getting there because you got to get down to sample rate resolution there. Yeah, that might be a little bit of a challenge for you there. There's no way to change that on that console? No way to change the resolution?
Most
of,
of those lower level inexpensive digital consoles don't have anything finer resolution than 1 millisecond.
Ouch. I call it a digital console.
The good news is, though, my church just bought Waves last week, so maybe I can figure out how to get it to work.
Well, I wish you luck. If you run into challenges, bring it to the lab, man. We'll try to sort it out for you. My friend Gear has a hand up. Let's see what he's got to say today. Gear, how are you, my friend? What's happening?
I'm fine. It's a bit late here in Norway, but I had a nap earlier today, so I'm awake now. I was just wondering about the drum thing. When you have the snare drum and the overheads and you do time alignment, so you have the mixer all set up like you show on the screen now, and then you find that, oh, I want to add whatever milliseconds to those microphones so that they are to the snare mic, so it's in time with the. So do you then add that millisecond across the whole mixer, or what do you do?
No, because that is, once your mixer is aligned, then you are doing a propagation alignment there. That time will be in addition to what is already on the console.
Only on that microphone?
Only on that microphone, yes. And you're going to head down a road here that is going to be, that can have some controversy in it, because, you know, and I'm just going to speak for me here. I'm not trying to tell anybody what to do here. I never do that. I never delay a snare drum up to the overheads. I just don't.
You don't?
I don't.
Why?
No. Because I want that spatial element in there with the overheads. I actually like that offset. I like what it does to the tonality of the snare drum. When
I concur. I never do it either. It's always natural.
But what Robert doesn't tell you is how high he puts his overheads up.
Well, and the other part of my overheads is it's part of the snare sound. I mean, I probably don't high pass it more than 200 hertz. I mean, just barely past the fundamental of the snare drum. So that overhead, and I think there are probably some guys in this room that would verify this for me. That overhead setup that I have is a huge part of my drum sound. It's not, it doesn't rely as much on close mics as you might think. Let's see, Justin, get in there, man. And then I got to move a little bit here. We're going to go way over time here.
Yeah, so can you hear me?
Yes, I sure can.
Okay, good. So you've talked about building a template and doing all these this alignment within your template. Is that assuming you know all the plugins you want on all the channels ahead of time, and then if you get to rehearsal and change something, your scheme is screwed up?
It's actually not, and so just hold on to that thought. And it's probably about time to move to this other part of the presentation anyway here, because I'm going to pull up a show file, a big show file that's already aligned. And we'll kind of go through how to do it, and I'll show you how to manage that situation right there when you want to make a plugin change. Okay.
Got it.
All right. So let's carry on with the little prezo here, because we're going to get into how we do this here. So I'm going to show you a manual delay compensation method here. There are some ground rules to doing this, and it is when you're getting ready to compensate. One of the things you have to do is ensure that all of your processing is in bypass, right? All equalizers, all dynamics in every section of the path that you're going to measure have to be in bypass, because you're going to use the phase trace to analyze this. If you're not going to use the phase trace and you're going to use polarity to create cancellation, even more important that you do this, because there can't be any difference between your source and your reference.
Got to be the same.
Yeah, they got to be exactly the same, or you won't get complete cancellation. Okay. So that's rule one. You have to be able to bypass all of that immediately or intently to do this. Second part is if you have times in there already, meaning you've already done a propagation alignment, maybe you've aligned your snare drum to your overheads, log that time, write it down, and then take it out. You can't have any delay on your inputs when you start here, okay? I mean, you can, but you're going to adjust them either way. All right, so if you've got propagation alignment going on, log what that is. If you've got alignment between your inside mic and your outside mic on the bass drum, log what it is, and then come back and put it in when we're done, okay? Third part is you're going to patch pink noise directly into all your channels, and we're going to, certainly in FFT mode, we're going to use that as the way to analyze what's happening, okay? So here's kind of the way I do it. So you can kind of see the signal path here. The primary thing that you got to do first is discover your longest path. And it might take a couple attempts to figure out what it is. You can kind of get some sense of it. In the show file that I'm going to show you today, and almost always in my show files, the snare drum ends up being the longest path, all right? So as you can see, there is a snare top, and it's going through a parallel compression return that also goes to a drum submaster that is assigned to the left-right, okay? And then goes up through a matrix. That's going to be our measure path, right? Our reference is pink noise just going up directly into a matrix as well and going to the reference of Smaart. Are you guys seeing that? So that's what we're going to compare. We're going to measure the difference between those two paths. Justin, have you got another question, or is that a leftover from before?
No, that's a leftover.
That's right. I'll lower it here, but no problem. Okay. So the first thing is you got to discover your longest path, because that's going to be your reference path, right? And then this deals with one of the questions. I'm sorry, I can't remember who asked this, but this is exactly how you deal with, well, what if I want to change a plugin midstream? Okay. So on that reference path, I actually add about 20 samples of delay, right? Because once we get this done, you'll see that I can change plugins on any channel that I want to, as long as my net time remains the same, right? I learned this the hard way, because if you don't do this on your reference channel and you change the plugin on your reference channel, now you have to go realign the entire console. Whereas if you put some buffer in there, you put 20, 30 samples in there, now as long as the net time for that long channel is the same, like if I take a plugin out or I put a different plugin in, I can adjust that 20 or 30. Like if I add a plug or replace a plugin that is 7 samples longer, then I'm going to take 7 away from that 20, and my net time is going to be the same.
Robert, can you quickly explain how you route the pink noise source to where you want to measure?
In this case, and you'll see this here as well, I'm going to show it in this next slide. In this case, it honestly does not matter. It only matters if you want to actually know the throughput of your console, because all of the measuring we're going to do is relative to the reference, right? Remember, at the end of the day, really, your longest channel is the reference. So once you delay locate that and get the time for it, everything else is going to be measured against that. So that pink noise could be direct out to the FFT. It could go, I take it the same, at least a similar length, where I can manage it a little better on the console. I just take it directly up into a matrix, and that becomes my reference channel. Right.
I'm talking about how you get it from your pink noise source to the input of whatever channel you want to check.
Oh, okay. So I'm using pink noise on the console to do that, not pink noise from the analyzer or from the Smaart.
Right, a plug-in pink noise, like a generator.
No. Let me show you this. 1 second for me, please. Here. So on S6L, I won't speak for other devices here. If you turn your pink noise on, and then you go to Patch Bay, and you go to my noise channel, which is here, and go to console, you have oscillator available to all of the input strips, right? If I pass the oscillator into my noise channel and it is on, you will have pink noise in your channel, as you see here. Right? This is the onboard oscillator just bringing pink noise directly into a channel. And then that channel is actually going out a matrix. This guy here, right? So it's just coming up there post fader. Oops.
But Robert, looking at your drawing, that channel could, the way I understand the drawing, that you introduce a delay in the in the first pink noise channel, or is that because you have the generator is the pink thing on the top, and then you send the signal into the snare top, and then you send it to the pink noise channel, then it goes through there before it goes to the FFT. So there is a delay in that. Am I just confused by your drawing, or is there?
No, you're not confused by it, because there would be a throughput time on the pink noise channel getting it up to the reference, but it doesn't matter, right? It doesn't matter, because we're going to, once we delay locate, everything is going to be measured against that time. Matter of fact, maybe I should.
Yes, but the thing, I would have assumed that the pink noise went alone into that pink noise channel, and then out of there you had two arrows, one into the FFT and one into the snare top.
Oh no, you're missing a hop here. There should be a hop right here. This doesn't go here.
Yes, and that
goes here.
So I would have assumed that the arrow coming from pink noise down to the snare top wasn't there, but that rather that line came from the output of the pink noise channel at the bottom.
No, this is pink noise generator simultaneously supplying pink noise to the pink noise channel and to the snare top. One generator supplying two sources.
Yes.
And then output of pink noise goes to reference.
I don't understand why you want to go through a channel before you go to the snare top, because then you have.
I don't. This does not go here to here.
No, I understand that, Robert. I just don't understand why you would want that pink noise channel latency in there, because you could send the pink noise signal directly to from the generator to the
reference output.
Reference output, yeah.
I do it so that I have a fader control for it, and you're going to see here. It doesn't matter.
Okay. I yield. Is that the American word?
Yeah. I mean, if we were getting down to brass tacks and you wanted to know the throughput of this channel measured against the reference, okay, I'll grant you that. But I mean, to do this, let me see if I got it on the next slide here.
Robert, I think what's confusing for people is, how are you routing your oscillator from the internal oscillator of your console to the snare top?
A similar deal here, which again, we'll see once I get to it here. But let's go there and do it. Actually, I'm going to need to load the show file here.
I'm not familiar with that console, Robert, but I know on a Digico you would just go to an alternate input. Is that what it is? It's an alternate input?
It's just an input I've assigned to it. No, and I wouldn't go to an alternate input here. Like, for instance, I'll just do it here because we're going to reload anyway. So these are all my
routing. Yeah, you have a routing.
These are all my processing
from the oscillator,
channels, right? These are all input processing channels. Well, now they all have the pink noise going into them.
That's what I wanted you to show, so people can understand that it's routing from the oscillator to the input.
You're changing the routing from its normal source to use pink noise as the source instead of the normal head amp.
That's correct. That's correct.
Gotcha.
Yeah. So let's go here. I think this will clear it up once you guys see it actually.
Well, that clarified it. That clarified it.
Okay, good. Good. All right. So once we get that alignment to that. Back here. Once we get this aligned to the Smaart, right, when we do a delay locator, right, from that point on, we just plug that pink noise into every other channel and adjust time here to get it to match the snare drum. Yeah? You'll see it. You'll see it.
Just a quick question, arbitrary perhaps. Why is snare drum your choice as longest?
Because it takes the longest to get out.
Because overhead.
Just by the processing he has.
Yeah.
Yeah. Okay. All right.
Yeah, because in my world, snare drum has 4 plugins on it. Because remember, I do a lot of analog emulation, especially on this kit. 4 plugins on it that go to a parallel process that have 4 plugins on it, whether I'm using them or not. And then that goes to a master bus that has 3 plugins on it. So that path just ends up being the longest. It's not that you're choosing it; it's choosing it for you because it's the longest path, right?
Just wanted to confirm that. Thank you.
Yeah.
And you're picking that by the reporting in the console. That's how you go, okay, I know that's the longest because the desk is reporting that the longest.
I might look at it initially to see how long it's taking there. I might just do some you know, some mental calculation there to go, yeah, it's probably that, you know. But like,
I mean,
for
if you
instance,
put pro sub harmonic on something, then good luck, right?
well, yeah, I mean, that was the example, because I took pro sub harmonic and drove it off of an aux, returned it to a channel, and took that channel directly to the matrix. That was the only way I was going to get it aligned, right?
Right.
And
exactly.
everything had to align back to that subharmonic, and it got way out of hand, right? Okay,
About
so
600
let's get going here. I got to reload a show file here, so stand by. I got to open up a new Pro Tools session too here. So, Smoke if you got them. Let's see here. That's, okay. Let's see. Hopefully this doesn't come blasting out. Okay. Yeah. Okay, so I've got a layout here. Let's get this up. Mr. Camera. Swing this out of the way for a minute. Okay, so what you're seeing here, we're just, for doing this, for the purpose of this demonstration, we're just going to time align the drum kit, okay, and make sure it's right. But this, as you'll see, the same process applies to everything. So what you're seeing here are my inputs, and it's kind of separated by blanks, if you can see it. So this is my drum kit. This is all the parallel returns for the drum kit, meaning I got that bridge channel and a spank channel. And then this is reverb and plate, or room and plate. And then as we get over here, this is the 3 auxes that are involved in the drum kit. This is the drum submaster, pro sub, which we don't even have to worry about. This is going to be the main left right, my main left right. And then I've got my matrices down here where you can see it. All right, so for instance, if I was to play the drums, you can see them come in here. No idea what that sounds like on the other end, but okay, everybody kind of get the idea there? All right, so to start this, I'm gonna remove some times here. So we've got to have our noise on. So here's my noise channel, and if you look, let's see here. If you look, you can see that coming into my reference channel on Smaart now, right? That's going back up through that matrix channel. All right. Now we're going to, just for the sake of doing this, if we have kind of discerned that our snare top is going to be the longest channel, we're going to patch some pink noise into that channel and check it here. So top, and we are going to patch pink noise into this. Okay. Now, what's the first thing that we need to do, right? We need to bypass all processing in that path. Okay. So I'm going to go to the snare drum. I'm going to bypass the plugins. I'm going to bypass the EQ, high pass filter, and low pass filter. Now I'm going to go downstream, and I'm going to go to my parallel compression, and I'm going to turn or bypass the elements of that as well. All right. I'm going to turn off the bridge channel. Really, we just need to take the longest path, right, which is the snare chop through the parallel compression, through the mains left, right, and on out. Everybody with me so far? Okay. I'm going to turn off my reverbs. We don't want that as part of the measurement here. Here's my drum submaster. So that should be the last bastion before it gets anywhere, right? So if I turn off my submaster. I have no left-right metering, right? As I turn it up, I got metering. And I should also have metering in my measure now, which is a little out of whack gain-wise. So I'm just going to fudge it here just for the sake of this. All right. So let's do this. All right, so as you can see, there's no time there right now. We haven't done any kind of a measurement or alignment or a delay finder in our Smaart, right? So we got to do that now. We got to know how long this path is that we're looking at. Oh, don't give me a hard time here. Okay, so you can see that the phase trace has got a little bend in it, right? That is because I forgot to turn off my plug-in processing on the main left-right bus. So do that. And you're also seeing why. Oops, I got one more somewhere. That one. There we go. You're also seeing why you have to have your plug-in processing and bypass, right? Because it's going to so dramatically mess with the phase trace, you'll never make a good measurement, right? So as you can see right now, that throughput on the console from the snare top all the way out is 10.60 milliseconds, okay? Now, all that we've done so far is just put the computer in alignment with our path here. We've put that delay in the computer to align it to this path to show us 0 phase offset between those two parties, right? Everybody with me? Okay, so now let's go look at something. Now that we've got that, we can mute it, and we're going to patch some noise into, let's just do the snare bottom. That's a great example. So let me just mute that for a second. I'm going to go to the snare bottom. I'm going to bypass EQ. I'm going to bypass, what else do I have to bypass? Dynamics and plug-in processing.
Can you use input direct for this?
Input direct meaning?
I mean, doesn't that just take everything out of the loop if you go to input direct on the channel?
No, I don't use input direct here because that takes the plug-in time out of play.
Copy.
Yeah. No, you got to leave. Yeah, you don't want to do that. That's part of what input direct does, is take any processing out of play there. But it doesn't bypass it. It takes it completely. It's a mimic.
Right. I thought it just bypassed it.
Right. We'll do this. Okay, so here we go. So noise is coming into snare bottom now, and voila, right? So obviously we got some time offset that needs to take place there to match it up with the snare drum, yeah? So in this situation, I used the exact same plugins on snare top and snare bottom, but I had taken the delay off so you can see it. So this should be 20 samples, should put this right back in line, right? Okay, let's look at another. Let's go to kick out. Let's take a look at the bass drum. And same sort of thing. I've got to bypass all the goods. And I'll bypass the time. And we'll turn it on. All right, so there is kick out compared to snare top, right? That's how these would try to add together if we didn't manipulate time here on the snare drum or on the kick drum to get it to exit the console at the same time as snare top, right? So I'm going to go, I'll go here where you can see me do it. All right, so you're looking right there. That's delay time. Right, I'm going to put it in circuit and just start taking it up, and you'll start to see that comb filter go away. And I'm in between samples there. Okay, so now all we've done right now is just verify beyond doubt that the kick drum and the snare top are going to leave the console at the same time. Right, that's the ultimate goal here.
Just like an analog console.
Just exactly like an analog console. And I'm just going to tell you something. I'm going to go out on a limb, say something controversial here. When you get this right, you're going to be amazed how much closer it sounds to analog when you're mixing on it. Not kidding. EQ, everything responds better, you know, when you don't have these offsets in there. All right. So if you also notice, you'll notice that my time was 54 samples, right? Well, the way I always keep track of this, because, you know, the worst thing you can do is reach up to grab, you know, the low pass filter and accidentally grab the delay time and manipulate it and go, frack, what was my delay time on that to keep it in alignment? So if you notice in my names, I have in parentheses the amount of samples that input needs to be able to be in alignment with the console. So notice it's 54 on the 54 on the delay. Get over here. And it's also 54 here, right?
Amazing.
Yeah.
I don't want to fluff you all here, but once you do this on your console and you hear what it feels like to mix with this, you'll never go back.
Robert, that's
Robert
based
just
on the
got
premise
everybody arrayed.
that you're using a lot of plugins or plugins on a lot of channels. Yes.
Yeah. And I'll let the cat out of the bag here. I'm not scared of it.
And you did mention last week how much latency does the Avid console have without anything on? What was that?
Without anything on, I think it's
samples.
just under 2 milliseconds input to output on the console to start.
Okay.
Just
because
input to output.
Yeah, I remember
input through stage rec.
I started a conversation with somebody else about that, and I'll get back to you about that.
Yeah.
So this is very interesting.
Yeah. So obviously we're adding time to it here, right?
Yeah.
So
one of the English desks has a couple of samples from input to output. And so I'm interested to find out how we're going to manage on that end of things and compare it to both.
Yeah, I think the Allen and Heath, I think is probably the lowest one that I know. I want to say it's somewhere in the neighborhood of.
It's 0.07 milliseconds.
Yeah, I was going to say it's somewhere between. It's under a millisecond. So
yeah, I spoke to Fernando a couple of days ago, and he mentioned between almost 1 to a couple of samples from input to output on the SSL. But that's to be debatable, I guess.
Wow, that seems impossible to me.
That's what I'm saying.
That's including A to D conversion.
Mm-hmm.
I think you're talking about bus hop to bus hop on the SSL is sample to sample is just one sample.
That I'll buy. I don't know any A to D converter in the world at any sample rate that is at one sample.
Same here. So I'm interested to see how that's going to play out. We touched base on it very briefly. And I told him I was interested to find out what his take on it. And he's got apparently a run around on doing exactly delay compensation manually on the SSL. So
Great.
I'm waiting to see how that plays out.
Well, I got a feeling that you guys are probably talking slightly about two different things there. If you're talking full input to output, it can't be one sample. If they're talking about once it's to digital through any output,
yeah, I think
okay,
he may have misunderstood my question, but I suspect that you're probably correct.
Yeah. Okay, so all of you probably are sitting there thinking right now, are you out of your freaking mind? There's no way I could do this on a show day. I mean, are you kidding me? And the answer is yes, that's exactly right. You would never, ever want to try to do this on a show day, right? You want to have this pre-built and pre-aligned, yeah? Hang on, I'm going to get to a couple questions here too. Dave Stagel, I'm sorry, Alex, you're first up, bud. Alex Bolis.
Yeah, sorry, Robert.
That's all right.
I'm just wondering about what is now difference or what problem I'm running into if I do this matching without the measurement system, just using the I call it the counter, which I have on the desk, which also shows the samples before after Sally's question with the 171 samples.
Yeah. Well, you can use it. I don't want to lead you to believe you can't use it. Here, I'll give you the, and we can go back to the hack here if you want to try to figure it out. I just don't trust it. I shouldn't say that. I don't trust myself to not account for samples here at times that might be going through a bus or whatever they're going through. You know, I want something, at least for me, I want something that's more assured that I know exactly what's happening there, right? So you could do the same thing here with polarity, right? Remember the polarity hack I showed you?
It's what we have metering. We're not infallible.
Right, right. So in this situation, we've got the bass drum up right now. We're going to measure that against the snare, right? So if I were to just reverse the polarity on that kick drum, and we're going to listen to it here. Yeah. I think we're going to hear a summed response here. Let me just check something real quick, make sure I'm talking about it. Yeah, so you guys aren't going to hear this here. I'll try to get this set up for our little review next time. Because really what you want to be able to hear is a summed response of your pink noise and the channel you're measuring. And if you can do that, then you can reverse polarity on this channel and start manipulating time until they completely cancel, and then flip it back out of polarity. Go back to a normal polarity. Now, you guys are listening to a different bus there. I can't get them summed together there. You can do that. Is that okay with everybody? You guys understanding that concept there? Same process, really. And you can see it on Smaart there. If I do it, it's right. Like if I let's see. Yeah, if you see a reverse polarity on that, look at the phase trace. It jumps all the way up to, or all the way down to minus 180. Dave Stagel, bring it.
Yes, I wanted to mention a couple of, turn off the,
we'll do this. 1 second, please.
Thank you.
There.
One thing I wanted to mention for people, since we're talking about plugins, if you're using this method with Smaart and you're looking at stuff, some of the manufacturers, if you're running through, say, a multi-band compressor or something with a crossover network in it, there are some manufacturers where when you bypass it, and I know this was the case on the original venue, and it might still be the case like if you're working in something like multi-rack or super rack, if you've got a multi-band compressor on there, sometimes bypassing it doesn't shut off the crossover network. So all those crossovers will whack out your phase trace and you will not be able to see it get in the line.
So even if you bypass those filters on the plugin itself?
Yes. And I just mentioned that because I've seen guys where they've got their vocals going into a group and they've got a C6 running on that group, and then it's going into, say, another C6 on their master, and there's all these different, like, you're just stacking crossover networks, and anytime you're going through a crossover network, we're just adding more and more phase to it.
Yeah, big time. Yeah. Well, that's unfortunate. I'll try to experiment with that.
Yeah, I don't know if the McDSP stuff does it. I don't have any of that. And it's one of those things that might not be happening anymore, but I know in the past that's something that's bitten me. And especially if you're trying to do something in parallel and you put something on your parallel that has a crossover network and you don't have that crossover network on the other one, it's not gonna, you're gonna be having the same issue as you have without the delay compensation, because you're adding more delay.
Well, I don't want to cause trouble here, but if I was stacking crossover networks, I might have some questions about why we would do that.
That's a whole other that's a whole other topic.
Thanks for chiming in, though. I'll check on that, Dave. I'll check on a couple plugins between now and the time we get back and see what happens here. All right, Ken Newman, go, man.
Well, I'm just wondering, the basic concept is that is the basic concept that you're adding a plugin that will add time to all the channels, even if you don't have any, say, processing plugins on them?
No, my plugin choices are based on what I would potentially do within a mix. I'm not adding them just to account for time. Is that what you mean?
Yeah, that's what I thought you were saying, was that's how you would get the whole console in line, is by adding them to the channels that you don't have plugins on. Or do you have plugins on every
I'm not
channel?
I'm not adding plugins to those channels. I'm adding time to those channels. Right,
like on the input stage of the channel?
Yep.
Okay.
Let's go take a look at violins here. That's a good example here. So here I have a whole bank of close violins here and stuff. So if you notice, this second violin, number 6, has 632 samples of delay added to it. Can you see it there? Right. So that's not a plugin that's doing that. That's the onboard delay. And
I see. Okay, so that's how you're doing it. Got it.
Every channel would likely have some delay component to it to do that, right? Now, I will say this, although it's very DSP inefficient to do this, if you wanted to put time adjuster plugins on all these and keep your delay, your channel delay available for propagation work, you could do that, but it's going to be a lot of, like I got 60 inputs of orchestra right here. There's no way I would do that here.
You better have 2 DSP cards.
At least, yeah. So, I was going to show you this anyway, just to kind of cop to it, like for instance, one of the things I do on my drum kit and bass guitar as well is I have preamp emulation on every channel, pulse X style equalization on every channel, and tape saturation on every channel, right? On every channel of the drum kit, because I'm trying to create an analog emulated path there. So obviously those channels can be significantly later than other channels, right? Obviously, I don't have that on the violins here, so I've got to delay the violins to get them to catch up with the other pieces of it. Is it making sense to everybody?
Yeah.
I might be able to
probably raising as many questions as it is making sense.
I'm sure it is, but and honestly, guys, this is open-ended here. We're all at home. I'll stay on this as long as you want to stay on this. If you go back and work on your stuff and think, well, wait a minute, I'm getting caught here or whatever. Let's do it, because this is not to get all fluffy about it here, but this is so important to get this right. We're messing this up big time out in the world, and our consoles don't sound as good as they could sound if we weren't doing this.
Robert, I remember you saying last week that you do not use delay compensation at all. You just do it all manually. Did you say that, or?
I did, yeah. I don't even, like if you use this method, you don't have to worry about it. All your double buses are already accounted for when you do this, right? Like,
but isn't the output delay on the venue consoles only affect if it's routed to its own output and not to the stereo bus?
Say that one more time.
The output delay knob on say a group, right, or a any kind of bus, that delay knob is for if it's routed to a specific output, and not when that doesn't factor into the mix bus, to your stereo bus.
That is correct. Yeah, that caught me very early on. I didn't mess that up after that, because it was on a festival. I screwed that up. But yes, what Sully is alluding to here, if you go to the output buses, and I'll do it here so you can see it. Like if we go to a group or an aux even, and we put this delay in place here, that is not, even if this aux is assigned to the left-right, that is not impacting that to the left-right bus. That is impacting it directly to a physical output, okay? So don't get fooled by that. If you want to manipulate time on a group bus, you have to actually insert a time adjuster or something else to do it, right?
If you bring that back in, that doesn't affect that.
Say that again?
If you bring that direct out back in.
I didn't address a direct out there at all. Where did you hear direct out?
No, I'm asking the question. If you were to take that delayed output and bring it back into the console, then it would affect where you route the fader you brought it back into.
Yeah, of course. If you physically patch that physical output back to an input of the desk, yeah, you would be able to hear it then.
That's more work than a time adjuster plugin, though.
That's way more work. Yeah, no doubt. Okay, so yeah, good call there, Sully, for sure. What was I just going to say? My brain got pushed left there for a second. Tell me, I mean, and be kind. What was the audio like coming to you with the drum kit running there? If I bypass all the delay, you think you'll be able to hear the delay compensation? Think there's enough resolution in it?
I would say so. I mean, it sounded like your mixes typically do, so I would say you would hear it.
Easy now. Be kind. Be kind.
That was a comment. That was a compliment. Sorry. If it came across differently, it was a compliment.
I'm just teasing you. All right, let me, so I've got to go back and patch the inputs back in there from Pro Tools. Stand by.
And if you're building a template, just so everybody knows, if you're building a template and delay compensating everything in your template, you can also build a snapshot that's got everything set as the oscillator, as just a patch being spec'd, and you could put oscillator in there and not have to do this manually.
Yep, that's exactly right.
Robert, real quick on this patch that you're doing with SXL, is anything that you've shown with the manual delay compensation, is that any different if you're on like a venue profile?
It is not. It would work exactly the same in profile. You would just have much lower times because remember, as I showed last week on that series of console, DSP is handling plugin and mix, right? All right, let me get this all put back in. I've actually used events because I do this kind of for demonstrations for people. I've built some events where I can, with the push of a button, bypass all of the time offsets so that you can hopefully hear it. So that's
another thing you could use your snapshot for, to bypass the plugins and the processing and EQs and that kind of stuff in your template.
What did we?
Yeah, I actually suggest you use an event to do it. It's much cleaner to do it with an event now. Less to manage.
Yeah, what did we do before snapshots?
I had somebody standing next to me going, "Don't forget to do that."
We had index cards.
I had Ted Leamy. Yeah. All right. Let me see what we got here. Oops, we don't want any pink noise, that's for sure. Okay, so let me figure out how I'm doing bypass in this particular show file. Switch. Okay. All right, so I'm going to leave processing off here for a second, and we'll just listen to dry drums. Maybe let's do it with bass guitar too. That would be good. That'll actually help drive it home a little bit. Guitars too. That's not all right, so that's just guitars, bass, and drums. And I'm going to quit talking for a second so that you'll be able to hear it. Let me get you a cue, a visual cue here so that you know when we're doing it. So you should see that time go into bypass. Right here, you should see this time go into bypass when the delay compensation.
And that's every channel we'll be going. We'll just see one.
That's correct, yeah. So let's see how it goes here. I don't know if you're going to pick it up or not across the net, but we'll get it here. right, so here's the real test for you. I'm going to start with it off and listen to that and think if you can hear the cues that say that's a non-time aligned console, right? Because that's the question here. Because that's the way you would walk up to it normally and kind of hear it and go, oh, okay, all right. And then when I kick it in, listen to the difference there, right? I mean, I can hear it dramatically over here. I don't know if you guys can hear it. So I'm going to start with it off. One more time here.
The snare time needs to change.
I mean, to my ears, it goes from there being a fundamental on the snare drum to not being, or starts without a fundamental on the snare drum, and then you hear one when the delay.
Just the roundness of everything amplifies.
Right, right.
I hear the smear between the kick and the snare big time.
Yeah, yeah. And you know, the piece to keep in mind here is this: if you walked up and heard it like that, and your reaction was, "I need some more bottom end on my snare," if you're anywhere around the cancellation adding, it's not going to get bigger. The cancellation's just going to get deeper.
You're just going to lose headroom.
Yeah, and headroom. Yeah, no doubt about it. Right. Any takers? Anybody buying it? I mean, when you hear this, again, not to go weird on it, but you know, like when I've done this for other people, and that, you know, they've heard their whole mix, and we kind of do this in-out thing. Their mind, you can see they're just going to go, "What the frack?" Because there's this element of separation and clarity that is there now with the delay compensation in, that is not there without it. You know,
I would put money on it. This is why a lot of people say I hate digital consoles.
I guarantee it.
They don't know how to use them. They turn them on and it sounds like this, and they remember what analog consoles sound like or what they think it should sound like, and they don't know how to get it that way by turning knobs, because this is a fundamental that has to happen that's irrelevant to what compressor you pick or what, you know, anything else you do.
Well, the irony of it is not lost on anybody, right? If you're picking some glossy plugin because it has some cool vibe to it, and you don't take care of the mix impulse and the frequency addition, all of that goodness is gone. Doesn't work. Actually works against you. You know? Ken Newman, go.
I was just wondering, if you're not using plugins, does this come into play at all?
No, remember the diagram where I showed you where the digital console is only using inboard plugin or inboard processing? It doesn't mess with this at all. That is all accounted for, right? Yeah. So
analog inserts would mess with this, though. I mean, if you were to patch an insert on a desk and use an analog there, it adds latency there.
Yeah, because of the A to D and D to A conversion, right? Now, the nice thing is it's a fixed time there, right?
Right. So any insert you do, they would all be the same amount of adjustment to get it all back to normal.
Right, right. Everybody follow that concept there? If you're doing an actual, you know, out of the console to a processor back to the console, you're doing an A to D conversion and a D to A conversion combined there, right? So those are fixed times. Those don't vary. And if that's an analog processor out there, then it's, you know, and honestly, this is how Midas did it in the early days. If you did an analog insert on the XL8 and some of the others, you know, they knew that time, as long as it was an analog insert, and they could compensate on the input side. They actually were the first console to offer that, from my understanding, from my memory of it. But if you put a digital insert in there, all bets off, right? Because it doesn't report that time. Groovy? Who is Matt McQuaid is in the house. Man, bring it on, brother.
So I was, not too much. I was going to ask, big picture, this is about everything hitting the summing bus at the same time so that you're summing in phase, thus exiting at the same time.
Correct.
It's about the summing bus, right? Big picture.
Yeah, ultimately, yeah. Yes, indeed. And then we send it up to the PA and screw it all up again, so it's no big deal.
Yeah, then I mess up the time a lot.
Then I blame it on you. That's right. All right. Well, we're way past the allotted time. That is for sure. Who else raised a hand here? Christopher Dean, go, man. I'll get you in there.
Yes, if you're doing this method and you have the automatic delay compensation on, does it make any difference whether it's on or not?
Yeah, I erred on the side of caution there in my world, because I actually did this a couple times with it on, and I honestly, I don't know what it does when you do this. In my situation, in this show file in particular, there are no double buses in play, so I don't think it would have compensated anything. And
ADC doesn't do any inputs, if that's what he's asking. The ADC does not compensate for any input path differences.
That's correct. Yeah. So who wants to try it? Who wants to be the lab rat and go out and try this a couple times? I think maybe at the next session we'll talk a little bit about maybe how to handle or manage a template with this, because like this show file, I mean, this was a huge show, but it was built from a template. I showed up at the venue with it already done, And keep in mind, let's go cover this just for a second, just so you can remember. We talked about what happens if you want to change a plugin, right? Well, let's go. I'll just take some. Let's go to the hi-hat, and notice that its time is Its time is 632 samples, right? So if I said, okay, well, you know what? I need a plugin on the hi-hat. Let me go do that. Well, as long as we keep that 632 number in mind, we're going to go here. Let's get back to here. I'll just jump one in here. Oops. I'm going to put a Whamby Jamby Pultec EQ on there. I'm going to insert it on the hi-hat, which I think is somewhere down here. All right. So now we've got, if you look up in the window, you can see that we have a hi-hat, or the hi-hat has a Pultec on it now, right? So now our 632 number is invalidated, right? We've added more time to it. So the question is, how much time did we add? We right-click here, 108 samples. So 632 minus 108, 524, is that right?
That is right.
So now we've added the plugin, we've kept our net time the same, and nothing should have changed in terms of the relative impulse of that input compared to the other ones leaving the console. Same thing would apply to that snare top, even though it's our longest path. That's why we put in that 20 sample buffer there, remember? Right? So, maybe the place, sorry, go ahead.
I just get it now. I just get it.
Yeah. Actually, we got somebody showing up now. Oh, maybe you got locked out. Kevin Fix, you got a question, go.
Hey, Robert, I was just wondering, I'm with a smaller regional sound company. We don't generally get pre-pro time and stuff. So if I did this with a template, if you could show that in a future, would be amazing.
Yeah, I was saying, I think I'll probably try to do that maybe next week if everybody's okay with this. We'll have a little quick review of this next week and then talk about template. Because I was working with Chris Anderson up at Anderson Audio on this very concept of showing up at your shows with your own template, to be able to use, because, in their situation, and I'm sure it's not unlike this for a lot of smaller and mid-sized sound companies, even if you're doing that, like if a client has hired you to come in and do the event, if there's an opening act that you're going to be mixing, well, you're going to get the least amount of time to build a show file, right? I mean, you're probably not going to get any time. So take that kind of festival approach of, man, if I can walk up, if I've got predetermined kicks, snares, toms, and you just make sure and plug those kick, snare, and tom mics into those channels, I'm going to do pretty good. I'm ahead of the game, right? It's not to say you're not going to have to change anything. You are, but at least you didn't have to start from zero. I mean, if you're taking that approach of starting from zero, with every show file you build for an upcoming act, man, you're sacrificing one of the biggest assets of digital, which is portability, right? Being able to start ahead of the game. I mean, I'll just say it. I have not gone to a show, whether it was a one-off or anything, in the past, I don't know how many years, without a template. And
think about mixing the Latin Grammys without being ahead of the game.
Oh man, no way.
Impossible.
No way. Couldn't do it. Who else
All
we got
TV
here? Michael Schwartz, my friend. How are you? Good to hear from
Good,
you.
my friend. Thank you so much for doing this. It's really illuminating. When you inserted the Pultec, the EQP1A, you subtracted time from that. Wouldn't that be additive?
No, because there was no insert on it to begin with, right? So the initial time was 6:32, right?
Right.
If I put the Pultec in, now the Pultec itself has added another 108. So then my net time there would be 632 plus 108,
Plus
which
108.
which would push it out of phase with the other inputs.
Gotcha. Okay.
The hi-hat has that much because everything else is so long, and it has nothing, so it needs the most amount of time to align it.
To be able to do that. And then does that include your 20 millisecond adjustment delay?
No, that's only on the snare top, which is the longest path and my
In
reference.
that. Okay, right. So you don't have to add that to everything
No,
else.
don't have to think about it. Yeah.
Great. Thank you so much.
That's only if you're going to change plugins on the snare top, which is your reference.
Very cool. Thanks for doing this, man.
Sure. Ricky Leon, go, man. Ricky, are you there? Okay, I'll come back.
I don't know why that didn't work. I was just wondering, how does this apply when it comes to mixing monitors for musicians?
Oh, I'm so glad you asked. So yeah, obviously you have to be really, really careful here, mixing monitors and doing this, right? I mean, I've created a 10.6 millisecond buffer on the entire console, right?
And then you still have, the output and then going to wireless or wedges, everything else. So
I mean, you wouldn't be able to do this probably for for somebody on in-ears for sure, you probably wouldn't be able to do this. But that said, would I do my drum kit if I was doing it this way? Absolutely, I would.
Right? Because I would think that you wouldn't be able to do that for for your vocal, obviously, because
heck no. Yeah, I mean, that vocalist is going to go bonkers with 10 milliseconds of delay on it. So you got to pick and choose there for sure.
So you want to pick and choose just like a group section, like you just said, just for your drums or doubling guitars, whatever that's in groups sections.
Yeah. If you're using a lot of insert processing there, then pick your families of instruments there and deal with it accordingly. Actually, I just looked at something here. We ought to play this here. I just noticed that I did not put my processing back in on snare bottom. I bet this is going to be even more pronounced now. Stand by. Let's do this. I missed one. Let's take that out. You guys with your hands up, just hang in there. I'll do in 1 second here. So let's have one more listen to that and do the bypass thing again. Let's see what it sounds like. So I'll start it out again. Made my own argument here. Well, I could hear it big time there. And, that kind of proved the point because the snare bottom was actually a whole lot later or a whole lot. Let's see, is that right? No, I just didn't have the processing in there. So the time was right. So yeah, interesting there. Interesting. All right. Let's see. Ken Newman, you're back. Come on. Come on, man.
Sorry for the stupid question, but when you inserted that Pultec on the hi-hat, you did something that gave you the latency of the Pultec or something.
I did, yeah.
What was that? Can you show that again?
Yeah. If you go to any channel that's got plugin insert on it, let me get where you can see my cursor here. There we go. So if we go here, right, in this area and right-click. Oh, actually, I got to be on venue to do it. Stand by. And I right-click. It's giving me the processing delay there. Sorry, I'll get that out of the way so you can see it. There we go. It's right here. So you can see for that entire channel, it's kind of grayed out. I'm sure it's going to be tough for you to see across the net, but that's telling me the insert path latency on that channel is 218 samples. You got me there?
I see that. Yes. Okay. Thanks. I had no idea how that was even possible.
Yeah, and you can also go to an individual plugin and see it as well. So if I just go to this guy and I right-click on the, let's see, you can see it. I right-click here, and I can see what it is for the individual plugin. So for that particular plugin, it's 31 samples. Right. Groovy? That's right. I'm sorry, Ken. I forgot you weren't here last week because we covered a lot of that last week. So no
sorry.
Sweat, though. That's all right, man. No sweat.
This is a good way for you monitor guys to decide which plugins you want to use by knowing what they have.
Indeed.
For sure,
Indeed.
for sure. For sure.
All right. Well, guys, we're right at the 2-hour mark here, so I think I'm probably going to knock it on the head here. I knew this was going to be a bloody one, a meaty one, but I hope this answers more questions than it causes right now. My advice to you is practice with this. Practice. Please don't go out on a show and just try to implement this. I did that in the early days just out of necessity. I had no choice. I was on tour the first time I tried to start doing this, and I messed it up more often than I care to admit. So get a console, practice with this a little bit, use noise. If you can use an FFT, all the better. If you got questions, you can try to throw them to me at the Squawk Box address, but I get so much email in that box right now, it's going to be tough to do it. So we'll have to try to deal with it here kind of going forward.
Robert, last question.
Yeah, go.
If you don't have access to the console, would there be an alternate option to that approach?
Boy, it's tough to do because we're talking about plugins here that are built on DSP, right? So you can't just use standalone software here, as you won't have any sense of time, and there's no way to pass audio there. So
would the desktop software give me the sample difference on the plugins?
No, because it can't pull out to the DSP, right? Yeah, no joy there. We're actually working on a solution for that. It's a little ways off, but just no solution right now. All righty.
Thanks, Robert. Appreciate it. That was awesome.
Thank you.
My pleasure.
Yeah.
And like I said,
Thanks.
we'll come back and review this again right at the top next week.
Thank you, man.
And
Thanks, Scovy.
Very much, Robert.
Let it brew and see how you do. Okay.
Thank you much, man.
All right,
See you
guys.
next week, man.
We'll see you guys. Bye-bye.
Yeah, share the doc. Let me know how you like it.
Yeah.
Thank you, Robert. Thanks, Robert. Thanks, Robert.
Thank you, guys.
Robert, you're going to have to go to a single topic next week.
yeah, no doubt.
I can't fit them in.
I knew these were going to get long after a while. No doubt about it.
Thanks for doing this. Appreciate it.
Is it helping you out? You think you got some ideas on how to do this? I mean, I know you've been trying to kind of working with this back and forth. I've been watching you on Facebook about it. So.
I mean, when I posted my method I've been doing it the way you've done it for, since I started using SXL basically. When I posted the whole Excel spreadsheet for keeping track of it, that was really just about for guys that are trying to be quick and don't have any way to check anything, here, just see what's reported and at least go there and you'll be as close as you could be without knowing it's exactly right, as opposed to not doing anything. You know what I mean? Yeah. That was really just a trick for, hey, this can be better. It's not exactly perfect. The FFT and Smaart is always the best way to do it. But here's a quick way to just go see what's reported, because obviously we know the math in the console is accurate.
Yeah.
So it's going to report what the plugin's adding, because the plugin has to report what it's doing. So it knows, and it's going to get you way closer than not doing it at all, was really my point about that with the spreadsheet.
Yeah, the place where it starts to get squirrely is if you're doing parallel buses. If you're doing parallel returns, like parallel compression, especially if you're doing that at the input side, that's where it starts to get tricky.
Well, and I'm doing an external summing amp on my current show, so it has to be done, with the time adjuster to get it to go correctly in time to the external source, the summer.
Yep. Yeah.
So yeah, I've been doing it the way you've been doing it. And the questions that I had were mostly just to try to get, I could just tell that I was watching the chat a little bit and seeing some things that were going by, and, the trying to get you to explain how you get it into each input was, I think imperative to a lot of people. They're like, well, how do I check it? So it was mostly for me to try to help you get the info to the other guys.
Yeah, no, I appreciate it. I do. Yeah, no, it's great.
I'm being a wingman, I think, is what I'm trying to do.
Totally. And I appreciate it, truly.
Right
yeah,
on.
I think the win, if we can get it, is just to get everybody to take it seriously. That's the win.
Absolutely.
And respect what it can actually do to your mix if you're not doing it. So, all right.
Robert.
Whoever's asking about the spreadsheet thing, I just, like I was just telling Robert, that's just to, give you a general, like, this is what time it should be, because the plugin is reporting that time. It's not necessarily going to get you exactly perfect, but it'll get you closer than not doing it.
Sorry, somebody else was jumping in there too. Was it?
Yeah, that was.
Well, I'm Eric from Mexico.
Yeah.
The thing is that I want to share is most of the people get lost because they think I've seen in this session is like, okay, I have to do this with this console, but they forgot the main reason, that is take account for the latency in every digital console. So they're split between, okay, I have to do this on SXL, but they think that they don't have to do this as well in other consoles. So that's what I see as kind of the confusion most people are in.
It was a fear of mine when I started to do this, because I didn't want people to think, well, I only have to do this on SXL. That's not the truth. All digital consoles have this challenge, to some degree, because none of them do input compensation.
And that's something I think you have to reinforce the idea that this is happening in all digital consoles, because at least if someone is interested in SXL, they're going to look at this and, oh, well, this is more complex than I thought, and think about that is something specifically for the console and not digital consoles in general.
Well, I mean, but, the thing that comes with that kind of openness with the Avid console, which is we're open to all manufacturers supplying processing here through third party. There's responsibility that comes with that, right? I mean, if we're talking about mixing on Waves LV1, well, yeah, that's a completely compensated environment, but it's only Waves plugins. If we start to introduce other parts, then we have the same problem. So
someone posted in the chat that he was feeling like this is something that is an Avid thing, and like you said, okay, if you make this system this open, you have the responsibility to show what can you do and what happens if you do not take these things in account.
Right.
But that kind of could lead to other thoughts like, okay, this system is so complex that I'll pass on it.
Well, it's as complex as you make it. I think the sin is to go into it and just make do all these inserts and think that everything is okay. That's not the correct way to look at it. You have to understand exactly what you're doing there in terms of.
I think a lot of people misinterpret that ADC just does everything, and they don't realize that it just only does buses.
Have to dispel that myth. Yeah, for sure.
But Eric has a very valid point, is that it is a good idea to reinforce, and you do that, and I've heard you do that before, so I know it. But people who hasn't heard this before, they may not catch on to it so easily.
Yeah.
That this actually happens on this is the case with all mixers. So just a quick thing. Did you on loudness? Just check that thing I sent you so you can review.
Oh, did you send me some docs or anything on?
I've sent you more than that.
Okay, I'll look through it.
I think, yeah, I sent it today. So this earlier this morning. So,
and
so
is it all is it all open to post publicly?
It will be, yes. Just read it and you'll see.
All right.
It's even better than you asked for.
Awesome.
Yeah.
All right, guys. I got to pull the ripcord.
Good night.
Here.
Good night. I have to
see
go
you
to
guys.
bed now.
See you next week.
Have a good one. Thanks.
Actually, I don't. Yes, I will see you next week. I think.
Thank you, Robert.
We'll see you guys. Bye bye.
Thanks.
Thank you, Robert.